Supergiant Games have set the standard for roguelikes with Hades and Hades 2. There are so many amazing aspects to explore in these games, but today we're zooming in on one of the core mechanics of Hades, the dash. At first glance, the dash may seem like a simple ability, just a quick movement from one location to another. But when we dig deeper, we see that there is so much more than meets the eye, and there's so much we can learn from this mechanic. So let's dissect it and learn how we can recreate it in Unreal Engine. Welcome to Games Dissected, the series where I break down popular game mechanics and show you how to recreate them in your own games. What makes the dash of Hades pretty interesting is the fact that you can dash through objects and over areas that are unreachable by just walking, but still always ensuring that the player ends up in a valid location. Also, like all abilities in Hades, the dash can be modified as you play the game. Meaning the dash distance, the speed, how many dashes you can chain in a row, the cooldown between the dashes are all variables that can change. So how is that done as well? And finally, the dash direction is based on the input pressed on the controller or keyboard. So you can dash in any direction regardless of your current velocity, meaning you can change your direction very quickly to avoid incoming danger. So collision detection, customizability, and input-based direction. These are the three main characteristics of the dash, and I will show you step by step how to recreate it, while at the same time learning how to think like the pro game devs that built this mechanic. As always, the full project files will be available to download on my Patreon, so if you want to get the access to the source code and support me in the channel, feel free to check that out. For this tutorial, I'm going to be using the top-down template, but with the WASD movement, similar to what you'd find in the third-person template. So that we'd have the same movement as in Hades. And the animation, I'm going to be using this one for the dash. This is the dash animation from Lyra, plus some visual effects from Paragon assets. And I'll be linking everything that I'm using down in the description. And if you don't want to recreate it on your own, you just want to download it, you can of course get it from my Patreon. So let's first build a super basic dash, just a mechanic that we take the player from one location to the other without any checks or anything in the middle. And I want you to notice the difference between the output of this method versus how it's done in Hades. So let's start by creating a new custom event and call it dash begin. And the first thing we're going to do is play our montage in our skeletal mesh component. And that's the montage I just showed you earlier. Then to move our actor forward, we're going to get their forward vector, multiply it by, say, 600. And then we get their current location and add that to this new vector. And this will be our new location, so we're going to set actor location to be equal that new location, which is basically just moving them forward by 600 units. And then when we press, I don't know, the space bar, for now let's just do it, when we press space bar, we call dash begin. And if we test this out, you'll notice that when I press spacebar, I kind of just disappear from one location and reappear in the other. It's more of a teleport and not a dash. While in Hades, you can actually see that Zagreus is dashing through the air and not just teleporting to another location. So actually to move the character over time from one location to another, we're going to be using a timeline and a lerp function to do that. So let's see how we can do it. Alright, so let's start by creating a new custom event and call it move over time and give it one input, which is the location as a vector where we're going to be moving. And then we want to store the current actor's location where they're starting to dash. So we're going to get that and make it a variable. Then we want to make sure to set the current actor's rotation to look at the location they're going. Just in case you dash in a location that you're not facing, we want to rotate the actor to face that location. And then we can add our timeline. So a timeline basically allows us to move a variable from one value to another over a certain period of time. So we're going to create a new alpha track and call it location alpha. And at time 0, the value is going to be 0, and at time 1, the value is going to be 1. So basically, we're moving it from 0 to 1 in 1 second. And then if you can make this curve however you want, so that it starts slow, goes fast, so you can play around with this curve to play around with how the dash actually moves over time. So now that we have a value between 0 and 1, we can use the lerp vector function, which takes two vectors and an alpha value. And it chooses the number that is based on the alpha value. So if it's 0, it chooses A. If it's 1, it chooses B. And anything in the middle chooses a value in the middle. So basically, this will allow us to make a function that sets the actor's location on tick. So on update of a timeline is on tick to go from the start location to the end location in 1 second. And then we're just going to call this move over time function in our dash begin and pass it the location, which is also just 600 units in front of us. Okay, now you'll notice that the player is actually moving and not teleporting, but it's too slow. And we can modify the timeline to make it faster by just changing this value to something like 0.3 seconds instead of 1 second. But now the animation is too long compared to the timeline. And it's also a static number, we can't dynamically change it. So how do I make this a configurable value that I can change it with power-ups and things like that, and also align it with the animation? Well, to do that, let's create a variable called dash duration, and this we can configure however we want to be the duration of the dash. And let's start it with like 0.3 seconds. Then we're going to modify the play rate of the timeline dynamically, but first let's default it to 1 second, so make it go back to this 1 second value. And before playing the timeline, we're going to get it, so get the name of your timeline, and say set play rate. And this is how fast it plays. 1 is normal speed, 2 is 2x speed, and 0.5 is half, for example. So what we're going to do is do 1 divided by the dash duration. So if the dash duration is 1, then the value is 1. If the dash duration is 2, then the value is 0.5, and so on. So then we configure the timeline to be dynamic based on this variable dash duration. And we want to do the same with the play rate of the montage as well, but we divide 0.8 because that's the duration of the animation. So 0.8 divided by the dash duration. And I found that also adding a small value additionally here, like 2, is good to account for blending in and blending out times. Now we have synchronized the dash duration, the speed of the animation all together, and we can change now just a single variable to allow the dash to take longer or faster, however we want. And while we're making things configurable, let's promote this 600 to a variable and call it the max dash distance, so that we can also change the dash distance from this variable. So if I do it like 1000, then I'm now dashing much further. But I'm going to keep it at 600 for now. Now we move on to the most important and most fun part of the dash, which is doing collision detection along our path. Right now, we don't check where the player will end up after the dash, which means I can end up inside of an object, or even worse, I can fall off the map completely. So how do we solve this? Well, we do this by doing capsule traces along the path of the dash. And what do I mean by this? Well, we have this max dash distance variable that defines how far the player goes when dashing. And ideally, we want the player to end up at the furthest possible location. So here's the algorithm we're going to follow. First, we're going to do a capsule trace at that furthest possible location. And why capsule and not sphere or anything else? Well, because the player's collision is a capsule. So we simulate the player standing at that location and then check if they will collide with anything if we move them there. Then if they don't collide with anything, and it is a valid location, meaning it's not off the map or anything, then we dash to that location normally. But if there is a collision or it's not a valid location, then we want to find the next closest location that is valid. So then we do another capsule trace, but this time we move it backwards towards the player's starting location and see, is this point now valid with no collision or not? And we keep repeating this process until we find the furthest valid point, or we end up at the start location, meaning we can't dash anywhere from where we are. Alright, so now let's implement it and replace the way that we're currently doing the location with this algorithm we just explained. So for that, we're going to create a function. Let's call it get furthest valid location along route. And this function takes two inputs, the start location and the potential end location. And both are vectors. And it returns a single location, which is the furthest one, as we explained previously. And we're just going to call the function here. And by the way, if you can make it a pure function by checking this checkbox, meaning that we don't need execution pins to call it. And the start is going to be the current actor location, and the end is just going to be the same one, the forward vector multiplied by 600, or whatever the max dash distance is. Now let's implement the function. We first need to do a few things. We need the direction that we're dashing along, and we're going to promote that to a local variable. Local means just it's in the scope of this function and not accessible from outside the function, because we don't need it from anywhere else. And we also need to know something else. We need to know the size of the capsule. Well, actually the diameter of the capsule. So to do that, we get the capsule radius, and just multiply it by 2, because diameter is radius times 2. And we'll also promote that to a local variable and call it the capsule diameter. Then we need to know the distance from the start to the end. So we're going to get this distance vector and just pass in the start and the end to know how many capsules do we need to spawn. So to do that, we just get the distance divided by the diameter and convert that to an integer just to round it. And this will tell us how many capsules do we need to spawn. So if it's 1000 and each capsule is 100, then you need to spawn 10 capsules to cover the whole distance. And make it a local variable called capsule count. And then based on this count, we're going to do a for loop. So we're going to loop from 0 to this count to spawn a capsule trace. And the trace we're going to use is multi-capsule trace for objects. That's very important. Multi means it can collide with multiple things, and for objects means we're going to tell it which objects to check for. And for the object types, let's just make an array and add all the types that we have. So world static, world dynamic, pawn, everything. I'm just going to leave out the physics body because you can collide with physics body and just push it out the way. So that's fine. We're not going to check for collision with physics body. Then we need the radius and the height of this capsule, and it's just going to be the exact one for our player. So we get the unscaled capsule size and the radius and half height from that. So we are simulating the same capsule that the player has. Now the start and end is interesting, and it's a bit more complex. So yeah, pay attention because this is going to be very important. We're going to get the capsule count, so how many capsules do we need to spawn, and subtract the index from it, so that we start from the end. So we're basically inverting the loop. And then we multiply that by the direction, and then multiply it again by the capsule diameter. So this tells us that, okay, for the first one, this is the location. For the second one, offset it by the capsule diameter. For the third one, offset it by the capsule diameter times 2, and so on. And then we add that to the start location. This gives us the final end vector of where we should spawn this capsule. And we're going to use that as both the start and end for our trace. So just to recap, we get the capsule count, subtract the index from it to invert the loop, multiplied by the direction, and then multiply it by the capsule diameter to offset the location every time by that capsule diameter, and then we add that to the start location. Next, we need to know whether this is a valid location or not, now that we have it. So we're going to create another function called isValid-location, and this function will take the location that we're trying to check, and also the array of the hit objects that the the capsule trace collided with. So this is going to be of type hit result and make it an array. And it's just going to tell us at the end whether this is a valid location, yes or no. So that's going to be a Boolean. So let's use that function just by calling it here and passing in our out hits. So every hit that came out of the multi-capsule trace, if any. And we also want to pass the location of the current loop that we're looping over. So let's promote that to a variable and call it the current capsule location. And just pass that to our function. And if the function returns is valid true, then it is a valid location with no collisions. So just return the current capsule location. And this ends the loop. And if false, don't do anything, means continue the loop. And if the loop completes, that means we never returned. That means that every point wasn't a valid location. So here we're just going to return the start location. That means we failed to find any valid location, so we'll just return whatever point you started at. And now let's implement this isValid-location function. Well, first, we're going to do a line trace by channel, by the visibility channel, to check if there is a floor underneath us. So we're going to start from the current location, and then we are going to subtract 500 from it, or add negative 500. And this does a line trace directly downwards to see if there is a floor. So we're going to do a check if it is hitting something. That means there is a floor, so it's a valid location. But false means there is nothing underneath us, so return is valid false, because that means there is no floor underneath us. And then if there is a floor, so there is a hit, we want to loop over all of the hit responses that we got from this capsule trace to check if we are actually going to collide with them or not as a pawn. So first, if it's empty, there are no hits. That means that the multi-capsule trace didn't collide with anything. So we return is valid true because, well, there is a floor underneath us and there is nothing that we collided with, so it's a valid location. But if false, that means there are some hits in this array. We're not just going to say it's not valid right away. No, we're actually going to loop over them to check what are they blocking, because maybe they don't block the pawn channel. So we're going to break the hit result, get the hit component out of it, and we are going to call the function getCollisionResponseToChannel and check what does this component do to the pawn channel, because we are a pawn. So if this response is equal to block, that means that this component that we collided with blocks the pawn channel, then it's not a valid location because it's something that's going to block us if we stand there. But if it doesn't block the pawn channel, we're going to continue looping and check once more. And if we complete the loop without returning, that means that none of them block the pawn channel, so again, it's a valid location. Now let's test it all out. As you can see, when I dash, I do a capsule trace to the furthest possible point. And if I can't go further or to the max distance, then I go as far as I can. And if I try to dash off the map or to a non-valid location, it's not going to let me. And you can see that the capsule traces aren't letting me go through objects that I can't get the end of, but if I can reach the end, I will be able to dash through objects normally. And you can see the capsule traces, just like explained in the visual algorithm earlier. We are trying to always find the furthest point. And this right now behaves exactly as the Hades dash, where you can dash through objects that normally you would be colliding with, and you can dash over areas that you can't reach just by walking. So excellent. Now we are one step closer to recreating the exact Hades dash mechanic. Now there are 3 things left to do to get this dash working properly. First one is add a cooldown so you can't dash infinitely like I can now. And the second is to add a dash count to define how many dashes I can chain in a row before the cooldown begins. And finally, having the dash be input based instead of now just based on the forward vector, which can cause some issues. So let's start with the input based direction. Right now, if I'm moving towards a location and I want to dash backwards in the opposite direction, that won't work. So you can see that I am moving to the right. I'm going to do it in slow motion, and then I press left and dash. I kind of dash diagonally because it's based off of the forward vector. And the forward vector didn't have time to change when I pressed the input. So we want it to be based on the input instead of the forward vector. So over here in our dash begin, where we calculate the end dash location, we're going to create a new function to do that and call it calculate dash target location. And it's not going to have any inputs, and it's going to have a single output, which is our location vector. And let's also make this a pure function, so we don't need execution pins to call it. So now we're going to need to get the direction based on our input. So there's a function called getLastMovementInputVector that gives us the direction vector based on the movement input that we're currently pressing. So we're just going to multiply that by the max dash distance to get our new vector, and add it to the current actor location to get the final dash location. And that's pretty much it. Except there is one single problem. What if we're not pressing any input and we're trying to dash? Well, then this getLastMovementInputVector is not going to be valid. So to fix that, we're going to fall back to the forward vector. So we're still going to get the actor's forward vector, and we need to check if the last movement input is valid or not. And we're going to do that by using a select vector node, which selects between two vectors based on a condition. So we're either going to select the forward vector or the last movement vector based on if the last movement vector is equal to 0. So if it is equal to 0, pick A, which is the forward vector, and if it's not equal to 0, pick the last movement input. And now you'll see that it's working as expected, and I can rapidly change my direction from left to right without waiting for the character to rotate to that new direction. Now let's input the dash count to be able to define how many dashes I can chain in a row. First, we'll need a variable called isDashing as a boolean to tell me if I'm currently dashing or not. And we're going to need two integers, a max dash count to tell me how many dashes I can chain in a row, and the available dash count means how many are left. So if I have 2 that I can chain, I used 1, then there's 1 left. So when the construction script, I'm going to set the available dash count to be equal to the max dash count. So they always start off at the same value. And I'm just going to default it to 3 for now. So back in the event graph here and in our dash begin, right before we begin the dash, we want to check a couple of things. First, we want to check if we are not currently dashing. So if isDashing is not true, and that the available dash count is greater than 0. And only then can we proceed with the dash, otherwise we can't dash. And just to make things a little bit cleaner, I like to collapse these sort of checks into a macro. So I'm just going to create a macro out of it, call it canDash. And then this macro is just going to have 2 outputs, a yes and a no. Right, so if yes, we can dash, we first want to set the isDashing variable to true. That means, okay, now we're currently dashing. And we also want to decrement the available dash count. So we get the available dash count and do decrement. That just means subtract 1 from it. So now we've used up one of the dashes, and isDashing is currently true. And when the dash is over, so we have finished the dash, we want to set it back to false. So the dash is finished when the movement timeline is complete. So on finished of this dash timeline, we're going to set isDashing back to false, which will allow us to dash yet again. So now if we test this all out, you can see that I can dash 3 times, but then I can't dash anymore because we never reset the available dash count. And this is when the cooldown begins, because now I need to start the cooldown and set it again. So we're going to create another function and call it the dash cooldown begin. And this function just sets a timer, and the value of that timer is going to be our dash cooldown time. So we'll promote it to a variable and call it dash cooldown. And let's set it to something like 1 second. And then when the timer is over, we want to create a custom event and call it reset dash count, which just sets the available dash count back to the maximum value. So available dash count is equal to max dash count. That means we can now dash again. And we just need to call this cooldown begin function right here in dash begin. So we're going to call dash cooldown begin, and it will start our timer for us. And now if I test this again, I can dash 3 times, wait a second, and dash 3 more times. Perfect. And the cooldown begins after all the dashes are complete, or if I do one and I stop and don't do anything else. And of course, we can change this max dash count to, I don't know, something like 6 or 5. And then I can chain 5 dashes in a row before the cooldown begins. And I can of course change it to 1. Now I can only dash once, wait a second, dash once, wait a second, and so on. And of course you can play around with the cooldown timer to fit your needs. Alright, now before I show you a side-by-side comparison of our dash versus the Hades dash, I want to do some final cleanup and polishing first. Okay, for one, we want to prevent the character from moving while dashing, so they can't rotate while the dash is currently active. So before moving, we're just going to check if is not dashing, and only then will we start to move. Next up, we want to replace the spacebar with an enhanced input action. So we're going to go to our inputs folder, actions, and right-click, create a new input action. Call it IA_dash. Open it up, and we're just going to add one trigger to it, and we're going to make it on pressed. This is very important so that it only gets triggered once when we press the key and not multiple times while we hold it. Then we're going to go to our input mapping configuration, IMC default, and add the IA dash and configure it to 2 keys, the spacebar on the keyboard, and let's also do the gameplay controller. I have a gameplay controller here, and I press the A button on Xbox, which is the X on PlayStation. Alright, now we can replace the IA dash with the spacebar that we had. And yeah, just gonna plug this in here. On triggered, we call dash begin, and everything else should work as expected. And finally, I want to clean up the variables we have here by creating a category, calling it dash config, and put all the variables that are configurable in there. So everything that we can modify to change the dash behavior, we're going to put in there, and anything that we shouldn't modify, we'll leave. So we can modify all these things, the dash duration, I don't know, make it a second, the dash distance, I can make it like, 2000, and then I have a pretty far dash, but also takes longer than the usual one. And now we have a highly customizable dash that you can configure all these values, maybe as you pick up power-ups or things like that. Alright, and now let me show you a side-by-side comparison of both the Hades dash and the dash that we recreated. And that concludes part 1 of Games Dissected. Let me know in the comments below which game mechanics would you like me to dissect next. And as always, thank you all for watching. Don't forget to like and subscribe if you found this helpful. Check out my Patreon to download the full project files, get more benefits, and support me in the channel. And I'll see you in the next one.